Okay, thanks everybody for joining. We'll see numbers going up still, so we give it a couple of minutes more for everybody to sign in, and then we'll kick off and we are sorting out there's Chris, and I'm allowing Chris to talk now.
Stefan, do you think they can see the screen now?
Yes, I think everybody should be able to see the screen, and I've just got Chris promoted to panelist, so I think that should work now. Chris, can you hear us?
Yeah, I can.
Fantastic. Sorry. No, that's okay. Sorry for that. I think, as I said, we are learning a little bit here. I think I got you maybe twice here, Chris. Is that correct? Or is it a different Chris?
I logged in using my personal account. I don't know which one we have, either C Nights or Nights at EPA. But as long as I'm in.
There is also Chris Gabriel on the panelist.
Yeah, list. Yeah, you got the wrong Chris.
Sorry, Chris. That's my bad. I'll move you back. My bad.
Good to see you, Saman.
Good to hear from you, Chris.
It's been many years. Yeah, I'm looking forward to the discussion. Thanks.
No worries. I'll just leave Chris here because I think it's easy to promote someone to panelist, but not the other way around. So that's okay. But I think we'll be fine there. Okay, we got 46 people in. I think I will just very slowly start to get going because I know we're all here for the science and not to hear me speak or see the holding slide. So welcome everybody. And I will not take much time before I hand over to the real thing. And just if you help me just very quickly. Oh yeah, thank you, Simon. So good afternoon or evening or morning to you all. I know this is with these global events. You have always people who are either late night, early morning, or somewhere in the middle with different amounts of coffee. So welcome to the first live webinar. And this is organized by the International Environmental Modeling and Software Society, which we usually kindly refer to as iEMSs. So I'm just most likely going to use the abbreviation because it's quite a mouthful. So the webinar is organized in collaboration with the journals Environmental Modeling and Software, which is published by Elsevier, but run by iEMSs, and the Socio-Environmental Systems Modeling, or SESMO, an open access journal which is published by iEMSs, but with support from several international organizations, including Modeling and Software Systems Society of Australia and New Zealand, and several others, the Integrated Assessment Modeling Society. So we are now aiming to host such webinars quarterly in the future and are really delighted to see such a great interest in the topic, which obviously is to quite a large extent as well, because we have been very, very lucky to have a great speaker and great panelists. So thanks all to you for doing this for us, and I really, really appreciate that. So on behalf of iEMSs, I would like to really hope to see you all in future webinars or other events, like the biennial iEMSs meeting, which is happening in July 2022. We are really hoping it will be in person in Brussels, but fingers crossed with COVID and everything. And as you can see from my background slide as well, we have co-organized some sessions at the ModSim Conference 2021, which happens in Sydney in about 4 weeks' time. Unfortunately, many of us usual attendants will not be able to go, but we do hope that because of the virtual event and the hybrid event that will be held, some of you may be able to attend that as well. And we have a close collaboration between iEMSs and ModSim. So without further ado, I will hand over to Chris to introduce the panel and the speaker and run proceedings from here on. Thanks, everybody.
Thank you. This is Christopher Knights. I'm sorry you can't see me. I'm having some minor difficulties, but I'm on the board of the International Environmental Modeling and Software Society and part of organizing this. And I just want to discuss basically the general structure of how it's going to go. First, we'll have a presentation on sensitivity analysis by Saman Razavi. And then after that, we'll go into a panel discussion where each panelist will discuss a rough response to the presentation, about 5 minutes, and then we'll launch into some question and answers. And the question and answer and open discussion will be, the attendees can enter questions into the chat, and then I'll organize them to give to the panelists and presenter to discuss. So a quick overview on each of the people that will be speaking today. First is Dr. Saman Razavi. He will be giving the presentation. He's an associate professor of hydrology and water resources engineering at the School of Environment and Sustainability at the University of Saskatchewan. His research is the science policy interface, bridging hydrological modeling and prediction of flood and drought to integrated management of water resources and decision and policy making. He develops methods based in systems and data sciences, including sensitivity, uncertainty analysis, and machine learning. One of the first panelists is Dr. Julie May. She is a research assistant and professor in the Department of Civil and Environmental Engineering at the University of Waterloo in Canada. Her research is focused on parameter estimation, sensitivity analysis, and uncertainty analysis of complex models. She is developing sensitivity analysis methods with reduced computational budgets and focusing on model structural parameter inference and sensitivity analysis beside the classic methods for model parameters. The next panelist is Dr. Clementine Prieur, is a professor at Université Grenoble-Alpes in the Applied Mathematics Department. Her research focuses on uncertainty quantification, sensitivity analysis, model order reduction, dimension reduction, robust aversion, non-parametric inference, and risk analysis with mainly environmental applications. And then our final panelist is Professor Andre Satelli. He is a visiting researcher at the University of Bergen at the Center for the Study of Sciences and Humanities. His research focuses on physical chemistry, environmental sciences, applied statistics, impact assessment, and science for policy. His main disciplinary focus is on sensitivity analysis of model output, a discipline where statistical tools are used to interpret the output from mathematical or computational models, and on sensitivity auditing, an extension of sensitivity analysis to the entire evidence generating process in a policy context. And with that, I'll hand it over to Dr. Razavi for his presentation.
Okay, everyone should be able to see my screen now. Okay, thank you, Chris. Thank you everyone for coming, and a big thanks to iEMSs for giving me this opportunity to speak in this event. Very exciting, and I'm very excited to be here. In my 15-20 minutes or so, I will try to address the following 5 questions. What is sensitivity analysis? Why is sensitivity analysis useful? How did sensitivity analysis, or SA, as a field begin and evolve to date? What are the methodological approaches to sensitivity analysis, and what are the challenges and opportunities looking forward? So what is sensitivity analysis? In the most general sense, sensitivity analysis, or in short, SA, is the study of how the outputs of a system are related to and are influenced by its inputs. The system in question in most applications is a mathematical model encoded using computer software that simulates the functioning of some real-world underlying system. And the computer model can be process-based or purely data-driven, the former solving a set of differential equations on spatio-temporal domains through top-down or bottom-up approaches, and the latter, data-driven, directly maps inputs to outputs using statistical or machine learning techniques. Inputs for sensitivity analysis can be literally anything, including model parameters, forcing variables, boundary conditions, initial conditions, choices of model structural configurations, and basically any other assumption or constraints. And the outputs can be any function of model responses, including fluxes or state variables that may vary over spatio-temporal domains, or objective functions such as a production or cost function in cost-benefit analysis, or an error function in model calibration. Why is sensitivity analysis useful? It is useful because it addresses several fundamental overarching purposes of systems analysis and policy support, including scientific discovery by exploring causalities and how different processes, hypotheses, parameters, skills, and their combinations and their interactions affect the system. sensitive analysis can augment our perceptual understanding of how a system works, allows us to run hypothesis testing and diagnose how a model of a system might be deficient, so we can improve model fidelity. Another purpose could be dimensionality reduction by identifying uninfluential factors in a system that may be redundant and can be fixed or removed in subsequent analysis. And this can simplify a problem at hand and make it more tractable and cheaper to solve, both computationally and conceptually. The other purpose is data worth assessment by identifying processes, parameters, skills that are dominantly control a system for which new data acquisition reduces targeted uncertainty the most. That also relates to a more general purpose, uncertainty apportionment, which aims to answer a critical question: when does uncertainty matter? And it does so by attributing prediction uncertainty to controlling sources of uncertainty to identify which one matters the most. And the last purpose to name here is decision support by quantifying the sensitivity of an expected outcome to different decision options, constraints, assumptions, or uncertainties. And sensitive analysis is actually a fundamental underpinning of any decision-making process. For example, where what-if scenarios or policy effectiveness are assessed by changing one factor at a time or by changing multiple factors at a time and see the impact on the result. Is sensitivity analysis something new? Of course not. Sensitivity analysis has been historically, but informally, a fundamental underpinning of scientific discovery and human decision-making. Consider, for example, the classic laws of sliding friction, whose discovery is commonly attributed to the experiments by Leonardo da Vinci in the 15th century. These laws state that the friction force acting between two sliding surfaces is proportional, that is linearly sensitive, to the load pressing the two surfaces together, but is independent of, meaning insensitive to, the apparent contact area between the two surfaces. So how were these laws discovered? By a series of physical experiments designed informally based on the basic principles of sensitivity analysis, changing one factor at a time in a system and assessing the impact on other things involved in that system. So scientists always needed to systematically acquire representative information about the existence or the strength of effects of one or multiple factors on another variable in a system. To address this need more formally, in the early 20th century, a paradigm called design of experiments, or in short DOE, started to develop based on statistics for the efficient design of various experiments, such as physical, chemical, or biological experiments. And this was a first step towards formalization of the SA approach, as it provides a unified set of theories to answer SA-type questions. Those types of experiments were, and still are, very costly and noise-prone. But later in the century, the nature of many of our experiments changed due to the birth and growth of computational power that enabled us to develop computer models, thereby running computer experiments of the real-world systems. So experiments that can be very complex and high-dimensional now can be run cheaply. So such powerful computing technologies demanded a modern paradigm for sensitivity analysis. And as a result, in the 1980s and 90s, the field of sensitivity analysis as a formal way of thinking started to materialize. And over the last 3 decades or so, many researchers and practitioners from a wide range of disciplines have contributed to the field of sensitivity analysis. The SAMO international conferences that started in 1995 has been the primary driver of breeding a community culture in this heterogeneous population of contributors to the field. And the journal Environmental Modeling and Software, as we call it, EMS, has also been a primary venue for publishing essay-type works. And in the last SOMO in Barcelona, we initiated a special issue in EMS on sensitivity analysis for environmental modeling that has recently concluded. And you can see on the screen its editorial titled Sensitivity Analysis, a Discipline Coming of Age. Thanks to Andrea Sartelli for its leadership. And there is a position paper in the special issue by a fairly large team of, let's call sensitivity analysis practitioners, convened in the last SOMO, pondering about the future of sensitivity analysis as an essential discipline for systems modeling and policy support. And as you already know, this webcast and in particular this presentation are based on this position paper. What is the status quo in terms of methodological advances? There have been a wide range of methods developed to date for sensitivity analysis based on different concepts and principles. And here I'm going to briefly mention 6 general and distinct approaches to sensitivity analysis. First, think of a model as a response surface that gives different outputs as a function of inputs. For example, here you see a hypothetical response surface of a model with 2 inputs and a single output. If you choose a point in the input space, then you can perturb each input around that point and run the model and see the impact on the model response. This way, we could investigate which input is more influential on the output. And by doing so, we would effectively look at the partial derivatives of the model output with respect to the different inputs. This practice, of course, has a long history of application, perhaps in all areas of science. It's now called local sensitivity analysis in the sense that the sensitivities are assessed only around a nominal point in the problem space, which may give limited insights into the model behavior. So perhaps the most intuitive way of globalizing this notion is to sample derivative information across the entire input space and then look at the distribution of those local sensitivity information. So this approach can be called derivative-based global sensitivity analysis. Another very commonly used approach to describe global sensitivity is based on the distribution of direct model outputs. And this, the idea is to fix each input or set of inputs and investigate how the distribution of model output changes in response to such fixing. Then the bigger the change in the distribution of the output due to that fixing, the more influential that fixed input is. Most commonly, the variance statistic is used to measure such change, but higher moments of the distribution or moment-free measures can also be used. The other approach to global sensitivity analysis is based on variogram analysis of response surfaces, and this approach recognizes that there is a specially ordered structure in model outputs that provides important information about sensitivities, in addition to derivative and distributional properties. So in some sense, this approach bridges derivative-based and distribution-based approaches while providing a spectrum of information about sensitivity of the model output to its inputs, including the structural properties of the response surface. And here is another distinct but more heuristic approach for sensitivity analysis based on regression analysis. Think about fitting, for example, a multiple linear regression to the actual response surface of a model as an emulator, and then look at the regression coefficient for different inputs as measures of their importance. The emulator, of course, can be way more advanced, but the general idea is if the addition of an input contributes significantly to the quality of emulation, then that input is influential. And what are the challenges and outlook of sensitivity analysis? My last question of this talk. In the position paper, we have identified 6 major thematic areas for pondering about the future avenues that will take sensitivity analysis to the next level, to be especially beneficial to meeting the challenges of complex societal and environmental problems. The first area is recognizing sensitivity analysis as a discipline, and sensitivity analysis, of course, as a formal field of research and practice is young. It has evolved via efforts by a heterogeneous population of scientists from a range of fields, and there are different schools of thoughts around it that might sometimes be inconsistent with each other. Because of that, at least partly, SA in many applications has been defined by methods rather than purpose. So collective efforts are needed to structure, generalize, and standardize the state-of-the-art in sensitivity analysis such that it forms a distinct cross-field discipline. And those efforts must emphasize teaching sensitivity analysis as integral to systems analysis and modeling and decision-making. And it needs to develop protocols for best sensitivity analysis practice that are transferable across contexts and applications. We also need to better link with sister disciplines, such as optimization and uncertainty quantification. And perhaps even we might need to launch a scientific journal dedicated to sensitivity analysis. The second area is sensitivity analysis for mathematical modeling. Of course, sensitivity analysis has already been extensively used to support mathematical modeling, but much work is still needed to realize the tremendous untapped potential for modeling of socio-environmental and other societal problems that are confounded by uncertainty. Sensitivity analysis can help us with the management of uncertainty by characterizing how models and the underlying real-world systems work, by identifying the adequate level of model complexity for the problem at hand, and to help us point to possible model deficiencies and non-identifiability issues, for example, and basically where to invest more to reduce critical uncertainties in modeling. The third area is about computational aspects and robustness of sensitivity analysis. Of course, computational burden is recognized as a major hindrance to the application of SA because you would typically need to run the model many times for different inputs to run a robust sensitivity analysis. And because of that, many modelers choose not to do sensitivity analysis for high-dimensional and computation-intensive models, to which sensitivity analysis is most useful. And there has already been significant efforts to address computational demand issues, for example, through various surrogate modeling techniques, but we need greater efforts to develop SA algorithms that are more computationally efficient, more statistically robust, and are able to provide credible confidence measures on their results. We also need new algorithms that can consume recycled samples, however taken, under the notion of given data sensitivity analysis. The fourth area is about the linkage and synergies between sensitivity analysis and machine learning. It is actually intriguing that there are vast commonalities between approaches used in SA and in machine learning, or more broadly in data science. For example, various methods used for feature selection in machine learning are based on principles of sensitivity analysis. Similarly, some methods for interpretability and explainability of machine learning are rooted in sensitivity analysis, but rather informally. So the recent revitalized rise of machine learning, particularly deep learning methods, could be further enhanced by formal theories of sensitivity analysis. Perhaps a very promising area would be to use formal SA to offer help in explainability and interpretability of machine learning, and therefore to build trust in machine learning models. And the fifth area is about sensitivity analysis and its sister discipline, uncertainty quantification, or UQ. The thing is, the relationship and differences between the two may often seem confusing to those who are new to either SA or UQ. And the point is, SA is a much needed complement to most UQ practices, regardless of whether it's forward or inverse UQ. And SA and UQ need to be better combined to support a variety of purposes, including apportioning uncertainty, handling curse of dimensionality, and so on. So SA can also help us address unknowns around distributions of inputs and their correlation structure in UQ, because sensitive analysis, by sensitive analysis, we can assess how sensitive our results might be to those unknowns. And more broadly, we can assess the sensitivity of uncertainty estimates, for example, to various choices made in the process of designing a UQ problem. And here's the last one, sensitivity analysis in support of decision and policy making. We already know sensitivity analysis has historically, but informally, been a major building block of decision-making process. For example, the classic and widely used concept of shadow price is based on the sensitivity analysis, because they quantify how much more profit one would get by increasing the amount of a resource by 1 unit. This practice can be basically viewed as one factor at a time, or local sensitivity analysis. Looking ahead, decision and policy making under uncertainty can significantly benefit formally or informally from advancement in sensitivity analysis. And sensitivity analysis can help us address critical questions such as where and how does uncertainty matter, how the impact of all important assumptions have been treated, where should we invest to increase confidence in the expected outcome of a policy option, and blah, blah, blah. In addition, the notion of sensitivity auditing, that is an extension of sensitivity analysis where system models are used to support policy, has already proved useful, as it is about the legitimacy of processes undertaken in the development of systems models for policy support. Altogether, the above points call for more cross-fertilization of different research and practice streams on SA across a wide range of disciplines. SA is, in fact, a multidiscipline, and it's a subject that is intrinsically of interest to multiple disciplines. For example, modelers, systems analysts are interested in identifying different SAs and how they can use those measures in their work. Mathematicians and computer scientists, on the other hand, are interested in more efficient ways of calculating SA measures, and decision makers are interested in the output and implications of sensitivity analysis in the decision problem context. So really, it involves different viewpoints. So the conclusion of this talk is an open invitation from the authorship team of the position paper for further discussion and collaboration with researchers and practitioners across every area of science interested in theories, development, and applications of SA. And in our view, over the next decades or so, sensitivity analysis will underpin a wide variety of activities around scientific discovery and decision support. So with that, I will turn it over to you, Chris.
Thank you, Simon. That was excellent. So moving on to the panel response and discussion, we'll turn first to Julie and lead off with this question of what do you perceive as the current perceptions and the misconceptions of sensitivity analysis? And how do you translate these and how it could be used? And what do you think are the biggest challenges preventing the use of sensitivity analysis?
Awesome. Thanks, Chris, and thanks, Saman, for this awesome overview, which makes it pretty easy to start answering those questions. So there might be some hot takes in my reply. So I sometimes get the feeling that sensitivity analysis is performed for the sake of deriving a sensitivity and index, as if it is a magic number you derive and just for the sake of the number itself. But I think sensitivity analysis is a really amazing tool to learn something. Like the way to get to those magic numbers is actually why you do a sensitivity analysis. So for example, which parameters you would pick, or which inputs to pick, which ranges you pick for those parameters. How do you sample parameters that might be correlated with each other, or what to do when 90% of your model runs actually crash because it has never been tested before with completely random parameter sets. And I think all these issues are appearing not the first time during a sensitivity analysis probably, but they don't go away by ignoring them. So they will carry through to any many query application, like the one Saman already mentioned, like automatic calibration or uncertainty analysis. So if it already crashed during a sensitivity analysis and you ignore it there, it will still be there, right? So I think sensitivity analysis is a really nice tool to see those, to see things in your model you might otherwise not see, or it might be more hidden. So in my opinion, sensitivity analysis should be an iterative procedure, refining parameter ranges, sampling strategies, or resolving even model internal bottlenecks like bugs, for example. A second thing I think I would like to mention is that sensitivity analysis toolboxes, like implementations or packages that are really great for people to start with sensitivity analysis, because everything is already implemented. You feed it with your model output and you get those magic numbers in the end. But what I see as a potential problem could be that the black box nature of these implementations might actually hinder gaining some insights into the models themselves, because they only focus on getting you a random number in the end, like, oh, this magic number in the end, but might, for example, not show you that your model crashed 90% of the time in between, because it's just making use of the 10% of model runs that actually gave you some model outputs. So like if you're like, I think we just need to be aware if we are using a black box implementation, we might lose something on the way. So, but don't get me wrong, I think those toolboxes are really great to get started, but I think there's a lot of decisions you have to make that might be already done for you in the toolbox and you might not be aware of it. And then my last point I think is I wanted to make is that we is the background knowing that our types of models and also the questions we want to answer with sensitivity analyses are constantly changing. And I think that's the reason why sensitivity analysis methods are an active piece of research, right? Because we now have machine learning models. We have models, especially I'm aware of in hydrology and land surface modeling, where it becomes now much more popular to have a modeling framework rather than one single model. So a framework where you have to pick one of different options for different pieces of your model, rather than somebody made that decision beforehand already. So you have to pick the model structure in the first place. So there is research going on dealing with model structural parameters, let's say, but it's an active field of research. So in the future, there will be even more sensitivity methods than we already have. So I'm sorry. So I think what I want to say is that it is really important to have an open discussion what sensitivity analysis methods can do, which decisions you have to make, which problems you have to solve to get to those magic numbers at the end. So I think Saman's position paper and the plenitude of other models are a really great summary and an example for this. And that's, I think, is really needed in sensitivity analysis because it's so complex and there are so many methods out there. So I think with this, I would like to hand it back to Chris and yeah, I stop here.
Okay, well, thank you, Julie. That was great. Moving on to Dr. Pierre, how do you think sensitivity analysis may help machine learning, particularly in relation to recent crises around fairness in machine learning and machine learning-based decisions?
Okay, thanks, Chris, for this very sensitive question of fairness in machine learning. So maybe first I should try to define fairness in machine learning. So what is fairness? So let me take, for example, the case of law analysis. So if you think about a court which wants to make decisions with a machine learning algorithm, what is a fair decision? So you want to predict the decision of a court, the judicial decision. And for that, you have some predictors and some algorithms. So some predictors, let's say X and algorithm F. But you have also very sensitive features that we can call also protected features or protected attributes. So let me think about the gender or the ethnicity, for example. And you want that your prediction with machine learning tool is, I would say, unbiased with respect to this sensitive feature. And it is what we will call a fair algorithm. So can sensitivity analysis help in detecting unfairness? Yes, there are some recent works dealing with that issue. So the problem is to explore the relationship between the sensitive feature, so the ethnicity, the gender, for example, and the decision of your algorithm. And to explore this relationship, you may think about sensitivity measures. And there are some recent works introducing global sensitivity measures, which are really targeted for this kind of application to fairness. So yes, there is a relation, and sensitivity analysis can help in fairness, unfairness detecting in machine learning. But what is important also is that machine learning can help in sensitivity analysis. Because as Saman said during his very interesting presentation, when you think about sensitivity analysis, people are afraid because it is costful and it requires a lot of memory. And if you want to make sensitivity analysis with very heavy code, then you have to think about meta modeling or surrogate models. And if you have, I would say, very high dimensional problems and complex problems, then machine learning tools can help in building your meta model. So in that case, you will use machine learning tools helping in sensitivity analysis. So both fields are really closely linked and can enrich each other. And so I come to the other point I would like to discuss. Should people be afraid with sensitivity analysis cost? Because it is well known that if you want to measure accurately the sensitivity of a complex model, it has some cost, and you also need some high memory to storage all your computations. But I think really with recent research, we can tackle more and more complex models. So first by building meta models, as I said, but also by thinking about grid deployment and running massive parallel computations. Also, you might think about iterative processes to tackle the issue of memory storage, because now you have some iterative procedures when you can throw away some of the runs and go on in your procedure of estimation of sensitivity measures. So really, I think that nowadays there are really recent progresses in that directions. Also, Saman mentioned the green sensitivity analysis, where you can reuse some computations. And this is also very important And an alternative to green sensitivity analysis is also to choose very adequately the samples. And this is related to the field of designs of experiments. So I think that sensitivity analysis is important by itself, but also in connection with many other fields of applied mathematics, like designs of experiments, meta modeling, approximation in high dimension, optimization, and so on. So thank you.
Thank you. Oh, there he is. And thank you, Dr. Prior. That was fantastic. Moving on to our last panelist, Andrea, do you want to finalize with your thoughts and comments on the future of sensitivity analysis and any response to the other panelists in addition to the presentation itself? Oh, and you're on mute. There you go.
Thank you for having me, and I really appreciate the presentation, and I think this is really a stimulating discussion opened by Saman. I think I will project a few slides quickly, if I manage, to tackle the issue. I had some time today to prepare for that. So blah, blah, blah. This is now in sharing, but it's not full screen. Let me see. But I'm trying to put it to full screen. Okay, now you should have it on full screen. So what to say about the challenges for sensitivity analysis? I will jump into the discussion immediately by saying that there is perhaps there are dangers in our community, in our epistemic community of sensitivity analysis. Are we perhaps provincial or parochial, or are we too insular? Why do I say that? Well, I'll justify this in a moment, but I think we should, in a sense, do a better job to engage with other discipline, and we have to contextualize sensitivity analysis both among number crunchers, but more broadly among those people whose group is growing today, which are in context involved into the sociology of quantification, because modeling, mathematical modeling, most of what we are engaged with is also can also fall under the big heading of quantification. And then I also mentioned the possibility of being duplication. I mentioned How to Be Seen by Number Cruncher. This is a very recent book, an excellent book by Scott Page, The Model Thinker, which suggests the many models approach. Many models approach means not using the same model with different values, but using qualitatively different models, like Newtonian models against the prisoner dilemma models. And this book, surprisingly, doesn't discuss uncertainty and sensitivity analysis to any extent. It discusses the Shapley value, but only in the context of cooperative games theory, one class of games which he applies. And something very interesting I found in this book, which is a suggestion for us, is that based on this book, Coursera, which is a private provider of massive open online courses, together with Stanford, made a course out of this book, which drew apparently 60,000 students. And surprisingly, the community of sensitivity analysis could never manage so far to achieve preparing one such MOOC. I think it would be very successful if we managed. I mentioned the risk of some kind of duplication. Okay, here you have a very recent article in Nature, where the thesis of this article is that people modeling COVID should learn from people doing climate change when it comes to dealing with uncertainty. I disagree with this article. I believe it's the other way around. But the reason why I show this is that they mention ensemble modeling as a situation in which thousands of versions of the model are run with a range of assumption and input to provide a spread of results, blah, blah. And you see my unhappy man and my emoji, unhappy, because this is what normally we would call uncertainty and sensitivity analysis. Apparently, we have here a quite established class of modelers who are totally unaware of that. Then I mentioned, what else I mentioned? Oh, I mentioned sociology of quantification. Are you interested? Do you think this is something which could also interest our community? If so, this is a very recent review written by Meniken and Espeland. Espeland is one of the mother of sociology of quantification, and I really enjoyed reading this article. So I just want to suggest it for your consideration. Another dangers which we might run into both internally in our epistemic community and outside is the existence out there of a generally, we would call it Cartesian mentality or reductionism or procedural utopia, which has to do with the idea that in the context of evidence-based policy, everything can be computed and simulated, roughly speaking. This is what procedural utopia would be. This has a long story. How do we engage with that? By reading about this long story. I now show here 3 books, but this is in a sense totally arbitrary, because there are many other books which you could read to the very same effect. I suggest Ulmin, Jerry Ravitz, and for the aspect of the Cartesian dream, which we could call Ricardian, which is the Cartesian dream in economics, Eric Reinert. And if you're interested, together with these authors, we also wrote an article where we discuss to what extent these dreams are dangerous. So the kind of collective imaginary, well, we assume that everything can be computed may lead to quite dystopian result. So if you're interested, you can go and give a look to this. Engage with other disciplines. This is what we did last year with this manifesto, where we managed to talk about mathematical modeling on a journal where it's normally difficult to publish. And we, to do this, we teamed up with a group of people coming from very different quarters. You have modelers, philosophers, sociologists of quantification, the same Espeland and Theodore Porter, epidemiologists, very large community. In a sense, if a community, we manage to engage with such a broad spectrum of discipline, we can probably get ourselves to be better known. One aspect of the reduction is the danger of technicism and neutrality. And the way forward here, and this is maybe my most pressing recommendation to the community, is to use sensitivity analysis to engage in what we call fantastic number, and what Theodore Porter called funny numbers, which I will explain in a moment. So monitoring, being vigilant against the production of numbers which are simply meaningless. For the neutrality, I suggest this kind of reading, the idea that we have to, as Page says, we cannot use one single model, we cannot use one single discipline, because models, discipline, techniques are not neutral. Every technique will point to a different solution, and especially in the context of policy, we should use different lenses to look at the real, and sensitivity analysis can be part of this kind of activity. I promised to explain what funny numbers is. This is Theodore Porter, one of the father of sociology of quantification. And funny numbers are those numbers which on the surface appear very serious, but underneath there is all a kind of scrambling for power, for profit, for position. And you see this very much at play in many of the numbers which have been generated. I make simply one example, the numbers of leading to the last recession produced in the context of the financial economy, pricing of derivative, and so on. So in the manifesto, we managed to say that if you really want to do a serious job of quantification, you have to assess uncertainty and sensitivity under the heading of minding the assumption. So really uncovering what drives any given inference when associated to a particular technique of method or models. And I think this is what may lead us to a useful role for our community, the community which, as Saman was saying, was built around the summer conference. If we strive to to provide an input to this activity of monitoring the numbers which are not there. I mean, the funny number to the fantastic numbers, because when fantastic numbers are produced, the trust of people in those numbers decrease. And this is something Theodore Porter discussed very much in his work. So if we can manage to provide, together with others, of course, this useful role of monitoring, I think we can make something useful. But in order to achieve that, we must establish sensitivity analysis as an authoritative discipline to be consulted in this kind of matter. This was my last slide. Thank you.
Thank you, Andrea. That was great. At this point, if there are any questions that anybody would like to ask to the panel or to the presenter, if they wanted to enter them into the text box, as we're waiting for those to come in, were there any other comments that previous presenters, or that Saman, did you want to comment on what other panelists had said in response to your presentation? Or if not, I have questions I can ask.
I can say a few words. I think this is a great event to hear really different ideas and views about the future. And of course, all of them, I think, have very well converged in this session. I just wanted to reiterate what Julie said, that sensitivity analysis is an iterative process. And what we do is not black box, like toolbox are not black boxes. And I think all of it perhaps relates to how to better educate the next generation of scientists and the sensitivity analysis practitioners to understand what sensitivity analysis means, how they should go through the steps and refine and refine. And perhaps related to what Andrea said, we need more courses on sensitive analysis, perhaps under MOOC, massive open parallel whatever courses. And beyond that, I think we should try more to have courses based in our own home institutions on sensitivity analysis, and try to teach this to the next generation of scientists.
One question that came up is, you mentioned, Saman, that the idea of having a very specific sensitivity analysis journal, and since it's obviously such a complicated field, but also so important to everything, what would be the best way to communicate to everyone, to all the different fields that really should be tapping into sensitivity analysis and having a focused journal?
May I intervene on that?
Absolutely.
I would. Thank you very much. I think it's not a very good idea, because, if you believe that I am right with the idea that we might see of insularity, of provincialism, of being, in a kind of our silos, a journal would do precisely that. I think we go out in many different journals and get to be known in other community rather than enclosing in our. I mean, we have now done many special issues, very often on the same journals, in a sense, right? So maybe we should, now try different things, go out and kind of colonize other communities. I don't know.
Any other thoughts?
So what I had in mind when I said that, so we have, for example, multiple journals dedicated to optimization, the theory of optimization, like Journal of Global Optimization, or engineering optimization. And I'm sure you can find many more. And when you look at their scope, so basically you can publish anything about the methodological development and application of optimization to a range of disciplines. And I thought we could at some point think of something similar for sensitivity analysis, a go-to journal really for really advanced sensitivity analysis works. And also the other thing is, often sensitivity analysis is confused with uncertainty analysis, UQ, these kind of things. And there are some good journals for that. And we publish in those journals. Anyways, so I thought we could more formally define that these are sisters or sister disciplines rather than, as it stands now, it's rather convoluted to me at least.
Julia Clementin, do you have any thoughts to add?
Yes, for the application, I was thinking that it is also very important to provide manageable softwares and also MOOCs to explain how to use these softwares without going with some slopes and maybe some errors with crash of the codes, as Julian said. So it's very important to provide all this information. And then a journal, I don't know, maybe for me, it's important to be present in the field of applied mathematics as far as new developments are involved, and not only in just a very short community. So it's my point of view, but it is very important to be present for practitioners and to, as I said, to provide efficient softwares.
I think my thoughts about the journal is that this would really help to, it's like if there would be a sensitivity analysis journal, it would really help to start communication between different disciplines, right? Like, because like right now, a hydrologist, if I do a sensitivity with a hydrologic model, I publish it in a hydrology journal. So I usually but if I would have a journal where all the sensitivity analyses would end up, I would maybe also see what they are doing in biology or something, right? So I think that would be really helpful. So that's really difficult right now, because like if you just Google for sensitivity analysis, there's also like, it's really difficult to find something in a different field, right? So that would really be helpful, I guess.
Okay, I don't insist on the journal, but I wanted to go back to what Julian was saying, that very often sensitivity analysis becomes perfunctory. This is another element I've seen very often, that you have two classes of sensitivity analysis, those done by the practitioners, which are, very well done because they are done by the practitioner, but they are not terribly relevant. Very often they concern models which are just made for the purpose of illustration. And then you have the sensitivity analysis which are not done, which is where the model is really important and of consequence, but for a variety of reasons, the sensitivity analysis is not done. So there is this kind of partition. So I think we should again. The second comment is for Clementine. Clementine, I was reading a book of algorithm by Louisa Moore, Cloud Atlas, and surprisingly, in the end of the book, when she says what could be done to solve this problem of the unethical algorithm which enter into the public sphere and create their own ethical environment, is that for those who develop this algorithm to go through those processes, which, if you read what they write, is what we would call a kind of uncertainty and sensitivity analysis, so mapping of the assumption onto the inference in a way which will be transparent to the user, and which I think this is really very interesting, that there's a kind of convergent thinking there.
Mm-hmm.
Do you have anything else to say? Did you want to respond to that, or are you good?
I think what I want to just reiterate is, I mean, we need more community culture, and this even on this panel, we have a heterogeneous or a group of people talking about the same thing, and that is because of the nature of multidisciplinary nature of sensitivity analysis. So I mean, building a community is difficult, and SOMO has been doing very well in general, but we need really to do much more, because a lot of time we see things develop in other fields, or effectively sensitive analysis that we developed, for example, 20 years ago. In machine learning, in feature selection, for example, you can find approaches that are very similar to Sobol method, but perhaps they're just unaware of those developments back in, I don't know, 80s in sensitivity analysis. Anyways, and again, a journal would be a component, of course, of many that could help us really to go that way and build that community of sensitivity analysis experts and practitioners.
We had a question on what's the best way to design SADOE and how to decide what the best combination of a particular sampling method with sensitivity analysis method. Is that clear?
How you can combine the design of experiments with sensitivity?
With sensitivity, yeah.
Yes, of course, there is a coupling between both, and some sampling will be appropriate for one estimation strategy and not for the other one. And I think there are still some place for novelty in that field. But of course, design of experiments is very important if you want to reduce the number of computations, because of course you have now very huge computers, but even for environment, it's not good to just think about running some very heavy computations.
One other question was, what are your thoughts on how practitioners use the results of the sensitivity analysis that's performed?
Sorry, what do you mean? What practitioner use sensitivity analysis for?
Well, after you've done your sensitivity analysis and you have your results, what would, I guess, you then do with them? Or what would someone who was counting on that sensitivity analysis do with them?
Perhaps I can respond to that a bit. I think this is the type of question that we've been dealing with that are, I would say, essentially wrong to be framed this way, because it means sensitivity analysis is framed by method than purpose. I would say before running sensitivity analysis, you have to have a purpose in mind why you would do sensitivity analysis, and then you know how the right method, what is the right method to choose and how to interpret your result, rather than going, as Julie said, take a toolbox, sensitivity analysis toolbox as a black box, run it, and then don't know how to interpret your results. And this is, I think, an argument that some of us, in particular the authorship of the position paper, try to make. Then yeah, you really need to put the purpose first rather than method.
Yeah, I very much agree with what Sama was saying, because really, as I said before, you see, either sensitivity analysis not done or done very poorly, or you see modelers doing numerical experiment without a design, without using a design of experiment, something a physicist would never do, or something a statistician would never do. Why modelers do that? And then you could continue with that. I mean, I just was reading recently the analysis of the social cost of carbon, and which is given as 51 or 172 dollar per ton of CO2. And then when I look what they have done, this is they have taken the Monte Carlo mean over distribution which are long-tailed. I mean, normally you would assume that modelers know that you don't take the mean of a long-tailed distribution, but this is not the case. How this happens? So really, there is a lot which where we could offer, some guidance, because we have worked on this, we have, studied this. We could, rectify some of this more obvious distortion, like doing a sensitivity analysis, doing an uncertainty analysis without a design of the experiment, which is really, in a sense, shocking.
Yeah, I think what would be also what's usually really nice for practitioners, if you have a more large scale sensitivity analysis, if it's not one particular model analyzed at one specific location for 5 years, and then you cannot transfer that knowledge. Like, you don't know, is it when I move to another location, is it the same? Is it different? How is it different? Mm-hmm. If we start doing, or like, in my experience, large-scale sensitivity analyses where you can draw conclusions that are not specific for this one model parameter, but rather than parameters that deal with evapotranspiration are more important in Southern California, but they are like 5 times less important in Alaska. Something like this, I think that is something that is really helpful for practitioners, if they just read a paper and take the results of that paper to transfer into their models, even if they are using a different model that was used in that analysis, because it's such a general conclusion, right? Because I hope, like, the model they are using, evapotranspiration, will not be super important in Alaska and not important at all in California, right? But like, it's going to be very similar. So if we are going away from that one magic number, like, which we specify to the 4th digit in that paper, but moving towards something more general, I think that is something for practitioners, right?
Yeah, yeah. I'm also with Arlan Pui, we're also working on that. I mean, why, since there are so many different formula for evotranspiration, why only one is used? Why we know very well that there are at least 20 which are available. This is another of these things which you say, what's going on here? There is some reason why, you know, and then, oh yes, it's a legacy, you know, there is a kind of trend, lock-in effect, but yeah, this should be a mathematical modeling. This shouldn't be a question of legacy.
Yeah, exactly.
And more precisely, maybe we would like to make a multi-scale sensitivity analysis, not only large scale, but we are interested in the relation between the different scales, temporal scales, spatial scales, and what happens if you switch from one to the other.
Yeah.
Sure. Different lenses.
We've gone over a little bit, but one last question, and I guess we can respond to this briefly, and then I apologize for not getting to the other ones. Where's my last question? How can transparency and sensitivity analysis? How can you make sure that the results in scientific papers are done properly? And even for the referees of the paper, it may or may not be obvious for them. Is there a way to have that aspect of it more transparent and better, I guess, refereed?
You have to make reproducible results. Yes, but it's when you write a paper now for sensitivity analysis or any other fields, it is the important point to think about, can people reading my paper reproduce what I obtain as a result?
Without forcing people to do a reverse engineering, you know, sometimes you have to do a reverse engineering to discover what people have done. This is, I mean, this shouldn't be necessary. People should give out their software and then people should be able to investigate. And then people should be able to reproduce and put questions. This is...
All right. Well, thank you very much. Thank you to all the panelists and to Saman for the presentation and for pulling this all together. I really appreciate it. Stefan, I'll pass it to you.
Thank you, everybody. So it's only again for me to say thank you very much. Really appreciate all the input from the panelists, the questions from the audience, and the people that attended. And as I said previously, we will have a quarterly event like this. So keep your eyes peeled and have a look at our website, have a look at our Twitter, and hopefully see you in either of these events or of the conferences that we usually attend. So thanks, everybody, and have a good rest of the day, evening, or night. And I'll see you all soon. Bye for now.
Thank you to the organizer.